So we are today going to continue with our ready equations, linear equations. We're going to be working a little bit with parallel and perpendicular, but before we do that, I want to give you a little blast from the past. Remember standard form? Yes. AX plus BY equals C. Remember, these are just placeholder for numbers. So what's an example of an equation in standard form? Give me an example. Yes, sir. How much? Give me a number. 8. 12.
6.
Okay.
4.
I think we got one. So what this is, if you were to graph this, what kind of shape am I going to get? If I graph this. A square? What? Well, what do you get? The solutions to this equation, when graphed, will form a line. Linear equation, it's just another way of writing them. We have other forms as well. We have, okay, this is called what kind of form?
Slope formula form. Slope intercept. Slope intercept.
Slope intercept. What is this one
Point
called?
slope. Point slope.
Point slope. Y minus y1 equals m times x minus x1. You recognize that, that's pretty good. So, but these are all ways of expressing solutions that when graphed you get a line. Now, I can go back and forth to all these different forms. So if I have y equals negative 2x plus 1, how can I put this in standard form? I want ax plus by equals c. What can I do here? Yeah, let's move the x over. And how do I do that? Well, this is negative, so I'm going to add. And again, the little hint to help you know, maybe a little check, is negative on this side of the equal. When you move it over here, it's going to be positive. Is this standard form? Ax plus by equals c. Yep. Is it any different? Are the solutions going to be any different? No. You get the same line either way. Now, point slope, I want to put this in standard form. Whoa, okay, what do we recommend doing here?
Putting y equals m.
Okay, let's do that. So let's distribute. So y plus 3 equals negative 2x. Right now, let's be careful. Negative times negative.
Plus 4.
Plus 4.
Minus 3.
Minus 3. Y equals negative 2x plus 4 minus 3.
Plus 1.
Okay.
2x plus y equals 1.
Well, right, so we have to finish, right? So now I'm in slope intercept form. And I go back and it says, wait, it didn't just want that. It wanted standard form. Let's add the 2x to the other side. And looky here. So it turns out this thing and this thing are just two different ways to express the solution to the same line, right? The same thing. So what I want you to remember is that no matter what form you're playing with, you get the same solution set. If you graph it as 2x plus y equals 1, maybe you make a little table and then you do it, you're going to get a line, the same line you get if you graph this, the same line you get if you graph this. Okay, they're all the same thing, even though they look different. Okay, so back to standard form here. There's some rules with these. Now remember our field properties. So if we multiply or divide both sides of the equation by the same number, they will still be equal. You get something that's equivalent. So right when we solve equations, don't we say, okay, let's multiply both sides by 2, right? And you still have equals because you have that property of equality. That's true for standard form. And we actually did this when we solved our linear systems. So if I have 2x minus 6y equals 4, how many equivalent equations? What about 1? And what I mean by this is, let's say both sides are multiplied by 2. What do I get? 4x minus 12y equals 8. Remember, we did this when we were doing linear equations and we were trying to eliminate, remember? Remember that? Remember?
Elimination method.
Yeah, remember the elimination method of systems of equations?
Yeah.
That's this. So the point here is, this thing, let me get rid of some of my marks here. 2x minus 6y equals 4, and 4x minus 12y equals 8. They are equivalent. And what does equivalent mean? The same. The same. They have the same solution. Meaning if you graph this or you graph this, same line. Yeah. So I could also divide everything by the same number. Let's say I divide both sides by 2. Right? everything gets divided by 2. Division property of equality. What do I get here? X minus y equals 2. Because what gets divided by 2? Everything. This is equivalent to this one and this one. They're all equivalent. Same solution. If you graph this same line. Does that make sense? Because some people have a lot of, that struggle to them. Does that make sense?
Yes.
Okay.
Yes.
How many of these equivalent equations can I write? Infinite number of them. How come you said that? Why is that, Ryan? Why? I can multiply. How many numbers are there? How many real numbers do we have? An infinite number. So I can multiply them all, and I'll get equivalent. I can divide by all of them. I'll get equivalent. So there are an infinite number of equivalent ways to express solutions. So let's see. I've got a U right here, which is on the paper somewhere. It's near the top, I think. Is it there? Oh yeah, it's B. So it's near the top. It says examples. Write 2 equations in standard form. Do you ever see where we are? Yeah. I want you to write 2 equivalent equations to this. Go. Anybody have one that they can give me? Oh, Ben, you have one?
B. I have X minus 3Y.
Whoa, X minus 3 was negative 9. How'd you do that? He divided everything by negative 3. So is that equivalent? Yeah. What happened? It's not good?
No.
You did it right? I think you did it right. Do you have one, Claire? Yeah, what do you have? And what did you multiply by? 2. Multiply all those things by 2. Do you have another one, right?
Negative 9x plus 27 minus 2.
Well, how'd you get there? By 3? Okay. Yes?
9x minus 27y.
Negative 81?
Yeah.
You're multiplying by negative 3. How about this one? 3x minus 9y equals negative 27. How'd I get there? I actually multiply by negative 1, but either way, right? You can divide by negative 1, same thing. So we can sit here all day, couldn't we?
Yeah.
There's an infinite number of these. So that makes sense. When I say I want an equivalent equation, that's all I mean. Multiply or divide through by the same number. So let's see what else we got here. So there is an infinite number of ways of expressing standard form, right? Look at this. We've already got 1, 2, 3, 4, 5 ways of doing it. So what we've decided to do is say, let's make a best. I don't know if best is the right word, but a kind of a standardized way of saying, this is simplest form when I'm writing in standard form, because otherwise we're all going to get different results, or we could. So we want to kind of keep it the same if we can. So here's the rules. You have to have coefficients that are integers. I'm going to put this up here. What is a coefficient? We don't know what that means. This is helpful. What's a coefficient? What is that? Yeah, so like this is a coefficient. It's what we're multiplying the variable, right? Okay, so they have to be an integer. What's an integer? What's an integer? Any number? A whole number, but that can have negative ones too, right? So negative 5, 4, 100, those are integers. What about 1/2?
No.
What about negative 3/4?
No.
Negative 0.6. Okay? So they're whole numbers, they can be positive and negative. And they can be 0 too. The greatest common factor amongst all these A, B's, and C's has to be 1. We call that being coprime. So it means there's no other common factor. So I'm going to look at the example that Matthew gave us an example, right? Are these coprime, or are there any coefficients, or any factors rather, other than 1? 2. So is this in my best form?
No.
No, I would have to divide them by my common factor. I divided everything by 2. Is this now, there's no other common factor among the coefficients other than 1? Yeah. So that's what I mean by that one. Okay. The leading coefficient, that's the coefficient up front, has to be a positive number. Well, what if it isn't? What if this was what I got? So according to these rules, is this in the best or simplest form? So So how do I fix that? I want the leading on the positive. What should I do, Ryan? Multiply everything through by -1. And what happens when you do that? Every sign flips. Okay? So these are my rules. So let's say I've got this one, and let me see, this is on your paper somewhere. Yes. Okay, can you find this? It's kind of in the middle of page 1. It says, write this in best standard form. Does everybody know where we are?
Yes.
Everybody there? Anybody not sure? Because I'll show you. You know where it is? Okay. So let's see, put it in standard form. Doesn't even look like ax plus by equals c. So it's in, what form is this called? Slope intercept. How do I change anything in slope intercept into standard form?
You, I'll add.
Well, I want it on the other side, right? If you're having trouble with it, do I add it, do I subtract it? Remember, when it goes to the other side, the sign will change. So it becomes -12x plus y equals -3. Do we understand how I got here?
Yes.
Make sense? If it doesn't, please ask. I don't want you to be lost on step 1. So we got there. Now I have to look at my rules. Are the coefficients all of them integers?
No.
This one's right, not an integer, it's a fraction. How do I get rid of the denominator? How do I get rid of it? Does it have to be negative? Yeah, it could be. But my first question is, you're right. My first question though is, what is the minimum I have to do to get rid of this? 2. Now he's saying -2, so he's kind of looking a step ahead. Let me just go step by step. You're absolutely right. Your answer is better than mine. But I'm going to multiply by 2, just to show you that's how you get rid of the denominator. So what do I get? Negative x plus 2y equals -6. Now his answer is better than mine. He said multiply by -2. Now why is his answer better than mine? Why is that, Ryan? Why was his answer better? Yeah, he was looking ahead. He said, what do you think this will do? I don't want to have a negative, so I did it in 2 steps. He would have done it in 1. I'm going to multiply now by a -1. Okay. What? Yeah, you could. That's what I'm saying. His answer was better than mine. I just wanted to break it down step by step so you can see what we're doing. He did it in 1 step. This was better. Okay, now let me see. Make sure all my rules there. All the coefficients are integers. We didn't check this. The greatest common factor among the coefficients is 1. Again, co-prime. I got a 1, a -2, and a 6. Can I divide by anything? Is there a common factor here other than 1? 2? If I divide that by 2, I get a fraction, so I don't want that. I think we're good. This is the simplest or best standard form version of this equation. And remember, equivalents, they're the same. You graph this, you're going to get the same line. Easier to graph this, I think. But sometimes we want it in this form. Questions so far? Awesome. Okay. Write an equation from a graph. So let's say I want this, write the equation of this graph in standard form. If I want this in standard form. All right, we do have this picture on your paper there. So let's see. How do we do this without standard form, right? How do you write the equation? Ben, how am I going to find this slope? What do I do? Do you remember? You got 2 kind of ways to do that. Yeah, how do you find the slope?
y2 minus y1 over x2.
Excellent. So there's my slope formula. It doesn't matter if this was x1, let's make this one the 1s and this one the 2s, right? So y2 minus y1. -2 minus 1 is -3. x2 minus x1. 2 minus 1 is 1. Let's put it in simplest form. What's another way of finding slope? Yeah, what's another way? Well, I just want the slope at this point. One way is slope formula. There's another way. Use the graph. I count these boxes. So start at one point. To get here, I go down 3, and going in the down direction is the negative, right? Vertical is always the top number. And then I go right 1, that's the positive direction, -3. Now what's another check? It is very common to make a mistake here and say it's +3, right? I've done it. Anybody else here ever done it? You got the wrong sign? So how do I check? Let's look at this. Positive, negative, 0, or undefined? Negative. Make sure then your number has to be negative, right? If you're going down, that's negative. Okay, so the slope is -3. write an equation. Now, if I could tell where the y-intercept was, all I have to do is y equals mx plus b, right? I can't tell where it is. So what do? I can't tell where the y-intercept is. I wish I could. You can tell. What do you think it is?
Because if you keep going up, up.
I don't know. So, what can I do instead? Excellent, right? The point slope form of a line can help me. Which point do you want to use? Just pick either one. This one looks easy, right? I'm certainly not going to mix these up, right? You ever mix these up and go the wrong way? No. So they're the same. I'm not going to do that. So y minus 1. This makes sense. And stop me if it's not, like, I don't know where you're going. Okay? Distribute. Y minus 1 equals negative 3x. Negative times negative. So be careful there. Add 1 to both sides. Y equals 3x plus 4. So you're right. And he was like, why don't you just go up 3 and you get to 4? So you saw that. But we can use this. Yeah. Yes. I didn't write any copy. Thank you. Okay, now, I'm almost done. This used to be enough. Let me write that so it's a little easier to read. I want to understand the form. What do? What do? Add 3x to both sides. And look, see, it's negative on this side of the equal. It's positive on that side of the equal. Now let's make sure it's the best one. Are these all integers?
Yes.
Yes. Are they divisible by any number other than 1, all those coefficients?
Yes.
No. Is my leading coefficient positive?
Yes.
Go on. There I am. Yes, sir.
If you have a slope and you have a graph of 2 points, couldn't you just, or 1 point, couldn't you just find what the y is by just, like...
That's what he said to do, but, you have to kind of figure it out. I want you to feel comfortable doing this as well in case it was like, this was 4,000, and it looked like it was going to get up here, and you can't tell just by looking. So, it's okay if you do the looking method and write it real fast. But be sure it's right, and I would plug those points in, put a 1 in here, and you work that out to get y is 1, put the 2 in, negative 6 plus 4, okay, negative 2. Then quick check. Alrighty, write an equation for, so again, nothing's real different from last time. It's just at the end, we're putting it in standard form. So here's 2 points, right? We find the slope. So y2 minus y1 over x2 minus x1. And hopefully, you know where we are, right? This is the last example, I think, or second to last thing we're doing on this front page. So negative 3 minus negative 1, that's a plus, right? And then 2 minus 3, negative 2 over negative 1. Negative divided by a negative is a positive. I'm getting a slope of 2. What do you guys think? Did I make any mistakes here?
No.
Is that good? All right, now I have to write an equation using point slope. Y minus y1 is m times x minus x1. What point do you want to use? Want to use this one? Okay. So there's my x1, there's my y1. So y minus negative 1 minus minus is a plus. Slope is 2. X minus x1, that's a 3. Distribute 2x minus this, right? And then I'm going to subtract 1s. It looks like I'm getting y equals 2x minus 7. I'm hoping I didn't make any mistakes here. Let's see, if I plug in the 3 times 3 is 6. 6 minus 7 is negative 1. Good. I'll even check this one quick now. 2 times 2, right? 4. 4 minus 7, that's negative 3. That's what I'm getting. Do you know what I'm doing now? I'm plugging them in, I'm checking. I just want to check because, anybody ever make a mistake doing this? Raise your hand, because I am. Always, right? Check it if you can. Now it says put it in standard form. So when you are in slope-intercept form, you basically want to move the x term over. If it's positive on this side, it will be negative on the other side. Okay? Now I'm kind of done. That is standard form. Is it best?
No, you have to.
Yeah, like the only thing that looks wrong with it is this negative. So if I multiply through by negative 1, sine flip, sine flip, sine flip, this is best. Not that this is wrong, it's correct, it's equivalent, but this is best.
Would you take that wrong?
It depends. If it doesn't say, it's probably okay. If it does say, give me the best standard form, then yes.
No, I wanna do the minimum. No, do the minimum. Do the maximum, thank you. Alrighty, vertical and horizontal lines. We reviewed this a little bit when we went over yesterday's homework, or last class's homework. For some reason, this is kind of a little bit of a mental block for some people. We just have a little trouble with it. So here's my XY axis, right? These are the black lines here, X and Y. Those are the XY axes. And it's a little hard to see in your paper because your paper is in black and white. So these are my XY axes. And it says Y equals a number. Now A is standing for a constant, just a number. Describes what kind of line? Yes, sir.
Y is a
Horizontal, which means left to right. Yeah? And X equals some number is vertical. And again, what if you're having trouble with this? How are you going to remember this? What I would do if you can't remember, pick 2 points and give them the same Y value. I don't care what you do. Same Y value. And then go ahead and graph this. 0, 4, 2, 4. You'll see it. If you can't remember, pick any 2 points you want, as long as the X values are the same. Graph them. 1, 2, 1, 4. You'll see that one develop. If this is still it's just not in there. So it's a way to get back there if you can't remember it. Okay, so we need to know that. So then, for Raper standard form, I can write equations of these horizontal and vertical lines now fairly easily. So I'm looking at this picture, and it's on the bottom of your page 1 there. Write an equation of this red line, and you don't have color. So the red line is the vertical line, this one. I want to write an equation of this. What do you think?
X equals 4.
X equals 4. How did you get that? Look at that. It's a vertical line, which means it's X equals. And what does X equal? 4. All right. Write an equation of this blue line. What is the equation of that blue line, a horizontal line? What do you think, Ben? What equals what? How'd you do that? Horizontal line is my Y equal. What does Y equal? -4. What do you think? Right? It's not that it's hard, but it's kind of, we got to be very clear which is the horizontal, which is the vertical. Now here's another question. I'm giving you a point, -4, 10. What's the equation of the vertical line that passes through this point? And if you're having a little trouble, draw a little sketch. So let's see, -4, 10. Let's say it's over here. And now I want the equation of the vertical, like your vertebrae, right? Up and down. What's the equation of this line? Noah? Awesome. How did you get that? The vertical is X equal, right? And it's -4. That's where it is. What's the equation of the horizontal line? TG. So a question like this, as long as we can remember these 2 facts, is not hard at all. The vertical is the X equal, the horizontal is the Y equal, and look what they are. X equals that, Y equals that. Remember which one's horizontal and which one's vertical. Questions about that? No? Okay. All right, so a little summary on this part. Standard form of equations, AX equals BY equals C. We can get an infinite number of equivalent equations by multiplying or dividing through by the same number. Everything, right? We can write an equation in standard form. Basically, just do what you've been doing to get slope-intercept. Do what you've been doing to get slope-intercept, and then put it in standard form by moving that x term to the other side of the equation. You may have to simplify a little bit to get it to look like that standard form. Horizontal lines are y equals a number. Vertical lines are x equals a number. Okay, so that's everything we just talked about. All righty. Now this is kind of an awesome little thing here. Writing equations of parallel lines. Let's see what we remember. We already know, we do know this, that parallel lines have the same slope. Nailed it. And different y-intercepts, right? Right? The same slope and different y-intercepts. You know what this little thing is? This little 3 dots? What does that stand for? That's math shorthand for the word therefore. Okay? Therefore, 2 linear equations that have the same what? Are parallel. Yeah, no, that's what I'm looking for. If they have, if you have, I'm going to make up 2 equations. Are these parallel?
Yeah.
Same slope, different y-intercepts. Therefore, a little thing here. So let's look at this question here. So pay attention. This, for some reason, I don't know why it's hard. It's not hard. But just pay attention, okay? Write an equation of a line that passes through this point and it's parallel to this other line. Let's just think about what they're asking. I've got this line, y equals 3x minus 1. It looks, that's kind of like this, right? Y equals 3x minus 1. I want another line. Write an equation of another line, and I'm going to use a different color. So it's going to go through negative 3, negative 5, wherever that is. Let's say that's over here. And I want parallel. I want the equation of the red line. That's what it's asking me to do, okay? Now, what do I know about the slope of this red line? Same as this one, right? Well, what's the slope of this line? N equals 3, right? Y equals mx plus 8. So this one has a slope of 3. If this one's parallel, it has a slope of 3. Now, I know one of the points on the red line. I know it has a point negative 3, negative 5. I have a point. I have a slope. What's the slope? Y minus y1 equals x times x minus x1. So y minus negative 5 minus minus plus. What's the slope here? 3. X minus minus 3 plus 3. Distribute. Subtract 5 from both sides. Y equals 3x plus 4. Now let's just compare here. Are these parallel lines?
Yes.
Is this point on this new line? Let's plug in the negative 3. What's 3 times negative 3? What's negative 9 plus 4? Good. I think we found the equation of my red line. Now what does it take? Did you write that in standard form?
Yes.
So, what is that? So I move the 3x over. If they ask, you don't always have to do that. Just practice. And we could leave it, right? But is that best? What would be best?
Five by negative 1.
I'm multiplying through by a negative. If they ask for standard. So it's just kind of pulling together what we did before. But questions on this. This becomes hard for some people. I just want to make sure. I don't want it to be hard. You find, they gave you the point. I know the slope will be the same as this line. Use point slope. Questions? No. Huh? Perpendicular is kind of the same thing. Now, perpendicular is slightly trickier. Slope is easy, right? Think of that, you have a tilt. Well, the parallel is going to have the same tilt. I can see why that slope is the same. With perpendicular, let's say I want a line perpendicular. Think about this slope. It's a negative slope, right? What does perpendicular mean? It means it makes a right angle. So if I want a perpendicular line, is its slope going to be positive or negative?
Negative.
Well, this one's negative, so this one would have to be positive. They are opposite slopes. Perpendicular lines have opposite slopes. So one's positive, one's negative. So I'm going to take the, I turn it negative or positive, right, depending on what it looks like. Now here's the tricky bit. If you're going down 3 and right 2, you're actually going to go up 2. You're going to go up 2 and right 3. It turns it upside down to get your perpendicular. It's a little bit harder to see. But the bottom line is perpendicular lines have slopes that are negative reciprocal. Let's break apart what that means. Oh no. No, it's okay. It's fine. You're gonna be fine, I promise. So negative just means opposite sign. That's all I want you to do. Take the opposite sign. That's the first thing you have to do. What is a reciprocal? What is the reciprocal of 2/3?
3.
So you change the numerator and the denominator. That's a reciprocal. What if it's a whole number? What's the reciprocal itself? Yeah, think about this as being 2 over 1. The reciprocal is 1/2. When you multiply a number and its reciprocal, you get 1. That's the multiplicative inverse property. So we're going to remember that. So what you do is you look at the slope, you take the negative reciprocal for the perpendicular, and so let's, all right, let's see if I can do it again. I'm going to go back to, what was this one? y equals 3x minus 1. And let's say I have that line. And now I want a perpendicular line. Let me find the point that I want it to go through. That goes through point, hang on, -1. Not that one, I'm just pick that. -3 and 4 say. So -3, 4, so over here. So which equation, I want this one, let me make that one red. This is the equation I want it to be perpendicular. So here's what you do. My original line has a slope of what? So my perpendicular line, what is its slope going to be? -1/3. Now where does that come from? Where did that come from? Negative reciprocal, which means you do two things. If this is positive, make it negative. If it was negative, you'd make it positive. And then you take this and turn it upside down. 3 is really 3/1. Take the reciprocal. It goes through this point. You have a point. You have a slope. Point slope. Y minus y1 equals your slope. X minus x1 minus minus. Here's my plus. Distribute y minus 4. Well, that's negative 1/3 x. Negative times positive is negative. What's 1/3 times 3? 1. Add 4 to both sides. So y equals negative 1/3 x plus 3. That will be this one. Okay? So it's a little bit trickier because you have to play with the slope a little bit, but otherwise the same. All right, you guys are fading out on me. Come back. Come back.
Baby.
Come back to me. Yes, baby, come back. All right. What about what is this? Parallel and perpendicular. So we have to kind of be a little careful with those. So if you have two non-vertical lines, do what I just did. Now, what if you know that there are vertical? Oh, this is like what we're doing here. I'm getting a little confused. I'm coming back. We did this already. I'm not doing that one. Determine if any of these lines are parallel or perpendicular. How do I know?
Slope.
Or, how do I know it's perpendicular?
Reciprocal.
What kind of reciprocal?
Negative.
Wait, negative reciprocal. So what would be my first step? And why am I doing that? Because I need to find the slope. So what's the slope of line A? Okay, now this one I got fixed a little bit. So I'm going to flip the x on the other side. And then what? And what gets divided by 5? Everything. So what's my slope here? Negative 1/5. Let's do the same thing here. Negative 10y. Add the 2x, right? Goes over there. Divide by negative 10, yes? So y equals, reduce this, negative 1/5 x. What's the slope? Okay. Do I have any parallel? Let's start with that. Are there any parallel lines?
Yes.
Which ones? Same slope. So B, here's the little symbol we use, parallel to C. Do I have any perpendiculars? A and B. 5, the negative reciprocal of 5 is negative 1/5. Oh, okay. So I write A perpendicular to B. I use this little upside down T. And to C. So A perpendicular to C. Make sense? Yeah? Who's got a question?
Wait, how is
Was that a brain explosion?
No. That I got.
It's working with slopes. Question, Piyush? How come? Because look at, what's the negative reciprocal of 5? Negative. And then you take 5, you got to turn it upside down. That's the negative reciprocal. Well, that's that. So they must be perpendicular. If you multiply these two numbers, you get negative 1. That's another way to think about it. And so that's the same thing. These are same slopes, they're parallel. Yeah. What is the negative reciprocal of 6? Negative 1/6. I should go back here. You're right. Negative reciprocal, what would be the slope of the perpendicular line?
3/4.
Right. Okay, is that better? Okay. Alrighty, let's write an equation, another example. So you write an equation of a line that passes through 4, -5, and is perpendicular to this other line. I would say when you see these, you want to make sure you understand if you're finding parallel or perpendicular. I like to circle that keyword, parallel, perpendicular. And if it helps, write a little note. Okay, so that one's going to be a negative of reciprocal slope. If it's a parallel, I would write safe slope. Okay, what's the slope of my original line? I'm going to draw the picture just so I can see what I'm doing. You don't have to do this, but just to help us while we're learning it. So there's y equals 2x plus 3. What's the slope of that line? 2. So the perpendicular line that goes through 4, -5 over here someplace, right? Perpendicular. What is the slope of this line? Going to be -1/2. How'd you get there? Take the opposite side, turn it upside down. So the slope of the original line was 2. So the perpendicular line will have a slope of -1/2, like this one. Now I want to write an equation. I have a point and I have a slope. Point slope. Here's my point slope equation. Write my formula down. I'm using point 4, -5. Right? They're going to give you a point. So y minus -5 minus equals this slope, right? This one. Perpendicular. X minus 4. Who's keeping up with this?
Oh, yeah.
Anybody I lost you about an hour ago. Are we okay?
Yes.
Negative times negative is positive. What's half of 4? 2. Subtract 5 from both sides. Y equals -1/2x minus 3. That's this equation. What do you guys think?
I like.
We like it? Yes. And that's what I'm using in point slope. Now, if it had said parallel, what would be different about this question? What would be parallel? Same slope. You do the same thing, except instead of putting a -1/2, you put 2. So if I wanted the line parallel, if I wanted this one, it would be y plus 5 equals 2 times x minus 4, and work that one through. And get this one. Yeah. What if the slope is negative? Okay. What if the slope is negative? It becomes positive. So by negative reciprocal, I don't mean it's negative, I mean it's the opposite. Opposite sign. Great question. Yes?
So, what if it adds four, so you down the parallel, and then you put it into the largest one, would we still have to put it in standard form?
Generally speaking, we don't go to standard form unless we have to. Because, I think this one's more useful for intercept. So if it doesn't say put it in standard form, you don't have to. Go to slope intercept though. Yeah, but if it says put it in standard form, so it means reading the question carefully. What if it said put it in point slope? Oh, I don't even want to go there. If it said put it in point slope, I'm done right here. So really pay attention to what the question asks, right? This is point slope, this is slope intercept, and -2x plus y equals -13, which I'm going to put in best form by multiplying through by a negative. This would be standard form, right? So we want to get very comfortable going from one set to the other. Alrighty, you try.
Oh no.
Yes, you do.
I got lost.
You got lost?
Yeah.
All right, I do one of these. Which one would you like me to do?
C.
Okay.
That was Brian. That was all of us.
All right, let's do, and ladies and gentlemen, think about what it's asking. You're given an equation, y equals -1/2x plus 1. And I'm just going to do a quick sketch of y equals -1/2x plus 1. And it looks like this. I want to go through 0, -3, and I want a perpendicular line. So again, let me go over that line with a different color. I want this red line. That's what they're asking you to find. Okay? One of the points on that line is 0, -3. So, I know the slope of this line, right? What's the slope of that blue line?
Oh, -1/2. -1/2.
So if I'm looking for the perpendicular line, what's its slope?
2.
2. Why 2, Sam?
Oh, because it's like
negative reciprocal. So this is a negative number, make it positive, turn it upside down. What's a point on that line? 0, negative 3, right, this red line? I have a point, I have a slope, point, slope. However, I also have what? What's this thing?
X and Y.
Y intercepts right here, right, isn't it? Starts with a 0, so this one's even easier to write. Y equals 2x minus 3. Or use point slope, that's fine, they'll get the same thing.
Wait, how is D negative 3?
Because look, 0, negative 3. It's Y intercept. Right there.
What about
So yeah, if you see it, you can save some time. But you can use point slope, it'll still work. Yeah.
D is not in Y equal to put in Y equal?
Excellent question. Look at D. It's not in Y equal form. I need a slope, right? So I suggest putting it in slope intercept form. Find the slope. Take the negative reciprocal, right? Extra step when you do perpendicular. Give these guys a try. I had a request to put some of these answers up. Oh, we can't see that. This is fine. We did that one, right? Oh, it said put them in standard form too. I guess you better do that. Oh, you. Yeah, I'm reading the question. It does say that. Come on. Oh no.
I got the answer.
Silly.
It does not say on ours.
I've got the slope intercept versions too, so you can kind of see what they are.
It doesn't say that on ours.
Says it here.
I know how to do it. I just got
There we go. Question. Parallel is the same thing. You basically, what is the slope of the line parallel to this one? So you have a point, you have a slope. Use point slope with that. Yeah? Which one would you like to do? Quiet. A or B?
I guess.
B. Okay. So, whoa, okay, this is, it's hard to find the slope, so I'll put it in slope intercept form by adding that 3x. So y equals 3x plus 7, right? So what's the slope of this one?
30.
Parallel lines have the same slope, right? So then it's this point and this slope. Y plus 2. Okay, hang on. So we add y minus negative 2, right? Equals m times x minus x1. That makes sense? Do you have a question there? Distribute. And then we're going to subtract 2 from both sides. So that's how I got this. Then I move that over. It became negative 3x plus y equals negative 4c. And then I multiply through by negative 4c. Make sense? So the parallel one's a little bit easier. One less step because it's the same slope. Perpendicular, one extra step, take the negative reciprocal of the slope. And that's it. I don't remember what this, I think this is summary page. Parallel lines have same slope. Perpendicular lines have slopes that are negative reciprocals. You want to know if lines are parallel or perpendicular, just look at their slopes. You can find different slopes by putting in slope intercept form. And we do this parallel perpendicular thing using point slope. If it's parallel, use the same slope. If it's perpendicular, use the negative reciprocal of the slope.